Okay, let's solve this particular problem. So this is the problem right here, and then this is actually the answer. This is the derivative, the implied derivative of this problem. So remember, we're looking at this kind of crazy loop-de-loo, and we're trying to solve what is the implicit derivative function in terms of dy dx of this particular function. All right, let's go back to scratch space. And here's what I'm going to do. I'm going to work through this problem, and you can check how I got to that answer. So the problem for this this loop-de-loo is x cubed plus y cubed equals 6xy. Okay, 6xy. So remember our steps to solve this. We're going to take the derivative in terms of x of this. So we'll do the dx of this. And we're going to take the derivative in terms of this. So the dx. Let's do this side first. This side will be really easy. We've got x cubed. What's the derivative of x cubed? Well, that's 3x squared. And again, we're using sum rule here. So plus, what's the derivative of y cubed? Remember, we use the chain rule to solve dx in terms of y. So that will give us, first we'll pop out part of it. That will give us 3y squared times, and then the derivative, so that was the derivative of this section. And now we do the derivative of the y itself, which can also be rewritten as y prime, or I'm going to do it, for this time I'll write it as dy over dx. Okay, so that y goes up to the top here. All right, so that's one half of my equation here. And then let's do the other half. So the other half, this is the product rule, right? We've got two terms. We've got 6x times y, right? Two separate terms, product rule. And what's the product rule? Well, here, let's label this one f of x. We'll label this one g of x. And if I think about that, okay, it was g prime of f of x, or times, sorry, let's rewrite this here. G prime x, f x, plus f prime x, gx, right? Product rule. So let's label this as g. Let's label this as f prime, or as f. So first let's just also find the primes of each of these. So 6, derivative of 6x would just be 6, right? That's the derivative here. Got to do this just like we did this one, or just like we did this one over here. So there's nothing to pop out, so it's just going to be y prime, right? Y derivative. So that's the derivative for the second chunk. So let's come back over here, and now let's compose those together like this. So we've got g prime, which will be y prime times f of x, which in this case is going to be 6x, plus f prime, which is just 6, times just g of x, which is just y. So to rewrite this, we would have 6x y prime plus 6y, okay? So that's the other side of our equation. I'm going to rewrite this so that it's the same term here. So it's going to be 6x times dy dx plus 6y. All right, so that's the other half of my equation, okay? So here's my equal sign between those two halves. So now just to rewrite that, we've got 3x squared plus 3y squared dy dx equals 6x dy dx plus 6y. Okay, let's balance it. Let's start by subtracting this 3x squared from this side, subtracting 3x squared from this side. Here, I'll do this in a new color so it's clear. So I'm subtracting this to get rid of it on this side and subtracting it from this side, okay? So that gives me this 6y minus 3x squared. That'll be this side. And then I got to move this 6x dyx over here. So that gives us 3y squared dy over dx minus 6x dy over dx. Okay, So now these are my new 2/2. I've moved all the dy dx's. Again, this could just be written as y prime, depends on how you want to do it, to one side. Now, what can I do with this side? Well, I can actually like factor and pop this guy out because I have two of the same terms here, right? So I actually have dy dx, and then in parentheses, I take these other terms, 3y squared minus 6x, right? So now I have dy dx on its own, multiplied to this whole term equals 6y minus 3x squared. How do I get rid of this whole term? Well, this whole term is being multiplied by dy dx, so to do the inverse, I just divide by that whole term, 3y squared minus 6x, and I do the whole thing over here, 3y squared minus 6x. Okay, so to rewrite this a final time, we've got dy over dx equals 6y minus 3x squared over 3y squared minus 6x. And is that our answer? Yep, that's our answer. I come back here, that is the derivative of this function. Now there's no, or not function, this equation, there's no way to type in the derivative here for this very easily because of how Desmos works. But we can verify that this is in fact the derivative for this particular thing.